we're here to talk about a combination of Couchbase as well as IBM BigInsights, and it gives me great pleasure to introduce Steve. Steve will be coming up in the second half of the presentation talking about the BigInsights product, which uses Hadoop as the backend with a lot of front-end tools for advanced analytics, and hope to give you a flavor of why these two technologies work well together, how they're different, but also how, when used together, they give you a lot more value that you can get from the solution. Let me introduce myself again. I'm Dipti Borkar. I'm the Director of Product Management at Couchbase, and I manage the product roadmap for Couchbase Server. That is our flagship product. You heard a little bit about Couchbase. You heard a lot about Couchbase today, and you'll keep hearing about Couchbase the rest of the day. And so in this session, I really want to focus on why these technologies are different, and how they can work together using our Hadoop connector that we've built. So with that, let's talk about the different kind of data management systems that are out there. We have the OLTP systems. Traditionally, we have heavy online transactions that are going on. Typically, these are these are systems that power web applications or your banks and so on. And on the other hand, you have the analytics systems, which traditionally, in the traditional world, you have EDWs, where you are aggregating content from all across all your regions and putting it into a single data warehouse. But things have changed. Things have changed with the kind of problems being different. Today, you have a large number of users, and you have a lot more information that you need to work with. And so here's the key difference between the two systems. The first one, which is, I call it OLTP, but we tend to call it interactive application management systems in some cases. But that's really meant for big users. Big users, when you have applications where you need to start off with maybe a few thousand users that grow to hundreds of users, and that grows to millions of users. And so NoSQL is a great fit for the OLTP systems that need to power millions of users. On the other hand, you have the big data problem, which is you have a lot more information to store and you need to process it. You need to make sure it streams in. You can store it at the speed that it's coming in. You want to get insights from this information so that you can do more with it, because just having the data isn't enough. You actually need to be able to look into the data, find insights, find recommendations for users, and then have some action that's performed with this information. And so big data is the problem that the analytics data management systems solve. Now, where does Couchbase fit in, and where does IBM BigInsights fit in? And this is where we think together Couchbase and the IBM BigInsights product, and there's a suite of products that Steve will talk about a little bit more. This is where we think it comes together, where on your OLTP system, you use Couchbase to power your applications, support millions of users, whether it's for ad targeting or whether it's for social gaming. And on the big data side, you have BigInsights to actually analyze that information, run Hadoop jobs if needed, use technologies like JQL, which is a query language for BigInsights as needed, and use other visual tools, analytic tools that non-developers or non-data scientists can actually use to come up with information and value out of these systems. And so, just kind of repeating what I said earlier, with Couchbase, you get the NoSQL database that's really low latency, great throughput. You could scale up to millions of transactions per second on a very small cluster. And with IBM, with BigInsights, you get the incredible power of finding those insights from your data. So let's take a look at a more real-world use case where you have a problem, two kinds of problems. One is you have the attention span, our attention spans to look at websites is just dropping every day, day by day. You look at a tweet, and then you look at Facebook, and then you go through Flipboard, and you add a couple of friends, and then you jump websites again. And while you're doing this, people are trying to get your attention to actually place an ad that's relevant to you. And so how do you get that kind of performance when people's behaviors are changing, their attention spans are reducing? How do you get that to happen? And this is a solution that we think would make sense, using Couchbase as the front end, if you may, of the system. This is where you get your low latency. You can power your application, get information, get the ads that match for this user incredibly fast. But at the back end, you're actually doing analytics with BigInsights, using Hadoop and MapReduce to actually find what ad is actually relevant to that user. So let's go into a little more details of this. So you might have a relational database on one side, and you have your application on the other side. But for the content-oriented side, you see that first your information comes in. The event may go into a couple of different places. So you might also use a relational database. But it goes into the Hadoop cluster. And from there, you get insights which match your user profiles, which then can be pushed back into Couchbase, and that's then used to actually render the ad when the user is on that application or on that website. But as he's clicking on information, he or she is clicking on information, you want to capture this session information, send it back to Hadoop, reprocess, reanalyze, so you can make sure that you're constantly giving very, very targeted ads back to this user, and getting your revenue generated, getting those clicks on top of those ads. And so this cycle where information comes in, it gets pushed down into BigInsights, gets pushed into Couchbase, and back is a great solution. We currently have a Hadoop connector for Couchbase, and that's what we're actually working on right now, building a integration with BigInsights. The Scoop, it's based on Scoop, and so it's a data transfer tool that was actually built for relational databases, but we've tweaked it a little bit and made it into a data transfer tool where you can export information from Couchbase, push it into a Hadoop cluster, and then import information from a Hadoop cluster back into Couchbase. And that's the key technology piece that connects these two technologies together. We work with the CDH distribution, and I believe IBM uses that as well, along with the Apache Couchbase distribution for their product. A little more details on how it actually works. So here you see the Scoop connector in action, where you might want to use it to export and import information back and forth. This is at a bucket level. So in Couchbase, we store buckets which are equivalent to a database. We use the TAP protocol, which is a streaming protocol that constantly streams mutations from Couchbase into Hadoop and then back again. And so the TAP protocol is what powers the Scoop connector, which is a Java-based connector. It's also open source, so you can feel free to download it and play around with it needed. Some more details about it. So now when you extend a single instance to a cluster on the Couchbase side, and you have a huge Hadoop distribution as well, you can do a lot more. So you can handle terabytes of information by going back and forth between the two technologies. So with that, let me hand it over to Steve to explain about the value that BigInsights provides and the tools available for end users, application developers, as well as analysts, non-technical users to use BigInsights for big data.
All right, so my name's Steve Beyer. I'm a program director in the IBM software group working with big data. And we have several products we've been building and also investing in through acquisition that I'll talk through. And my style, when I pitch, feel free to interrupt me, raise your hand if you have questions, or we'll take them at the end as well. So what you see here is kind of our starting chart on some of the use cases that we've done that have been high profile. Our first big high profile one was around Vestas, which is a wind energy company. based in Europe. And what they used BigInsights for was analyzing weather data over a long period of time so that they could determine exactly where to place those capital assets. All right, so each one of those wind turbines is about a $20 million capital investment with an expected lifespan of 20 to 30 years. So when they put it in, they need to make sure they get it right, and they get it right the first time. They dropped their analysis process from about 8 days down to 2 to 3 hours once they invested with the system, started using MapReduce and the underlying Hadoop-based technologies with the advanced analytics that IBM is investing on top of that. Brocade, a local partnership that we have here, we're working with them on identifying network security issues and also taking advantage of some of their fast switching technology. So that's been an excellent partnership that we've been doing with them as well. That's also been integrated with some of the IBM hardware for some of the high-end, non-commoditized opportunities that are in the marketplace as well. IBM is taking a very interesting approach with big data. I've been around the company enough to see how we do things and don't do things. And generally speaking, we don't embrace a market opportunity as aggressively as we have embraced big data and Hadoop. Right, usually we'll go out and just acquire companies, as you've probably seen through various news reports. I think right now we have $6 to $10 billion publicly advertised as our bucket to go acquire companies. But with big data, we started with streams, which is data in motion, doing analysis on the wire over a period of time, as well as BigInsights, which is our distribution of Hadoop. And we have two flavors of that distribution that we put out in the market today. One is the basic edition, which is free. So if you wanted to go to the IBM website, you could download it today, no charge. And that's designed to basically compete with Cloudera. But in the typical fashion of big companies, we also partner with Cloudera, so there's cooperation that's going on there. So if you have a CDH installation, we can apply some of our advanced analytics on top of that, or you can use the IBM flavor. And we also have BigInsights Enterprise Edition, which has a lot of additional enhancements that we've put into the product over time, and I'll explain those in a later slide. The idea there is that some shops want to go with hardened infrastructure. They might be interested in changing out HDFS into a more secure and scalable file system, bringing in LDAP technologies, working with things like text analytics and other technologies that we've built out from research. So it's been an exciting effort to watch. I think we've publicly advertised that we've invested $100 million so far, and that is just the beginning. So big data from IBM's point of view is here to stay for quite some time. So this is just more info on the Vestas use case that we've done. So yeah, reduction of about 97% from weeks to hours on the modeling time for wind forecasting information. So some impressive results came out of that one. And that was a combination of working with IBM GBS, which is our services division, as well as some folks inside a software group. So the IBM Silicon Valley lab, which is about 45 to 60 minutes down the road on your way towards Gilroy, is where this product is primarily developed. And several of the folks in that lab worked on this account directly. All right, so IBM Watson. How many of you saw the Jeopardy game last year when we beat the two champions? All right, so for anybody not know what Watson is in terms of this game? Okay, so I won't go over that part there. But fundamentally, we built a computer that was able to beat the best Jeopardy champions in the world. And it was a fun show to watch. And the underlying technology for that, a lot of it, of course, was built out of research, and it was running on some of our fastest computers in the cluster at the research center. And they built the studio at the research center because they had to tie in directly to those computers, and they couldn't do it over a wide area network, of course. But the pre-processing of a lot of that data when they loaded it into batch, the MapReduce functionality and what have you was done through the early versions of BigInsights. So we're proud to say that we had a role in this. It wasn't the only role, of course, but it was a big part of it. The data analytics baby, this picture might look familiar because you may have seen it as a TV commercial. This was based off of a real use case that we did in Canada, and it was using our streams-based technology. So all of the different sensors that go on a baby in NICU were hooked into streams, and instead of just having one sensor giving you one result, we started to aggregate and correlate that data together to look for patterns in real time on what was happening to the child. And what we were able to find is that we were able to start to predict about 24 hours in advance when certain babies were going to have an infection that normal medicine was not catching. So they were able to proactively treat that and reduce the impact from having that issue. And then IBM liked it so much we made a cool TV commercial out of it. So telco, so we're spending a lot of time with telco. doing a lot of stream-based analysis, looking at how we can measure dropped calls, customer sat associated with that, and correlating that information together. The CDRs that you see there, those are call data records. So there's about 6 billion call data records per day, and we're analyzing that in real time. Processing time was reduced from 12 hours to 1 second. That's a big data, boost if there ever was one. And everything right now is do it on demand, right? We need that information. We need it now so that we can act on it. Because if you're a cell phone user and you call into customer service and they know that you've had problems recently with dropped calls or whatever the case may be, now they can actually in real time dynamically update the call tree so that instead of pressing 4 for technical support problems, it's press 1, or have the person answering the phone say, hello, Steve, thanks for calling. Are you having dropped call problems? Can I help you with that today? Right? That's impressive, and that's taking full advantage of the analytics on demand. So these are some of the paths with streams. Once again, streams, from IBM's point of view, is analysis on the wire, real-time information flowing through the system. And the telecommunications use cases are a very popular one. We're working with all the big telcos that you would expect IBM to work with inside of the enterprise. So that continues to talk about in a little bit more detail, the 6 billion call data records per day, deduplicating those, and then running them through the system, doing analysis in real time, and coming up with the results. A brief history about streams that's kind of interesting is, for years it was a top secret project inside of the government. So shortly after 9/11, back in 2001, the US government started looking for real-time analytic tools to try and figure out patterns to help defend the country. And they didn't have any tools that worked well. So they went to IBM and said, we'd like you to build one for us. And so research started on a massive project with about 200 people on it for several years, figuring out how to do all of this, do it in memory, do it on the wire, and meet the requirements that came out of the federal government. They delivered successfully on that project, and then eventually the government said, okay, you can go ahead and release this commercially, which is what IBM, of course, would always want to do. So it actually starts with the 3-letter acronym agencies that were looking to secure the country after 9/11, and it became publicly available probably about 4 years ago or so. And we've been building on it ever since. So this is one of our architecture charts, and I think the next one here dives into it. I won't go into these in too much detail just because after lunch they can put you to sleep probably faster than the food can. But from a big data platform point of view, we have several different products that are coming together. We started off, as I mentioned, with streams, which is represented here on the left with this nice little lightning bolt icon, which is data in motion, data on the wire, and then internet scale analytics, which is our distribution of Hadoop. All right, and so like I said before, that's the basic edition that's free, or the enterprise edition with a lot of different features on top of that. And then as you move up the stack, you get into the visibility layer, where we provide analytical tools to not only manage the system but look at the data. So we ship some products with the enterprise version that we call Big Index, Big Sheets, which is an Excel-like web interface that allows a business user to start taking advantage of map-reduced data on the fly without having to bring IT into the mix. So it's a pretty cool story. And then the solutions was when we get into specific use cases and what have you. So anything here that's worth speaking about? If you're familiar with Hadoop, you know about HBase and Pig and Lucene, et cetera. All of the underlying open source components are identical. We have committers that we've brought into the organization over the last few years, several of them from Yahoo as those businesses were shifting. Always looking for more good committers, by the way, but that's beside the point. The components that you see inside of BigInsights, frankly, is pretty much a one-for-one match against CDH and the other major distros in the marketplace. So we have to go beyond just the raw open source code that Apache's providing and that we're working on in order to differentiate ourselves, which is why we get into the different tools and the use cases that we're talking about here. The screenshot up in the upper left is part of IBM's notion of having if you will, an enterprise application store, where we're providing more and more app-like functions into enterprise software, which is a relatively novel thing. Obviously, Apple kicked off that marketplace quite well in the consumer marketplace, but adapting it to the enterprise is a whole nother step forward. So we're putting together or providing APIs to allow customers to roll their own if they're interested, and then trying to provide a lot of accelerators to get that started for them. And as we get more requirements and more use cases that we bring into the system, we're providing more of that functionality to the enterprise level of the product. So those are some of the quick and dirty background on big data. We also recently acquired a company by the name of Avissimo. They're based in Pittsburgh, Pennsylvania, if you've heard of them. That was a large acquisition, and we look at it as Facebook for data at a very simplistic level. I'm oversimplifying it, but think of it as a way to have query and search rolled together, and data representing itself and the relationships dynamically through their portal system. So it's a very cool product. Other investments and acquisitions are certainly in the works. IBM's not shy about its acquisition strategy, but we do see big data as one of the biggest disruptors in technology in the information management space in, really realistically the past decade, maybe two at this point, and it's only going to get bigger. So we're just scratching the surface now, and we're looking forward to continuing to work with Couchbase and other partners in industry to drive this technology forward. And with that, I think it's time for Q&A, right? So the question was, one of the slides had a response time of 1 second. What's the data size, and what does that really mean? So the 1 second response time here is referring to the telco case of call data records, all right? So before, they used to process the call data records in batch. And so maybe on a nightly basis, they'd go through and they'd try to analyze them. In a lot of cases, they wouldn't even analyze them if they were too big, because they didn't have enough time in the batch window to get it done. So they'd do it over a broader time horizon and aggregate it and just look for generic patterns instead of specific problems to the individual user. So they wouldn't necessarily know that Steve had 25 dropped calls today and he's used to having 5, so he's probably really unhappy with AT&T. Not that that ever happens, right? And so what we did here is putting it on the streams wire, processing it in memory in real time as it happens, allowed that number to basically collapse to real time. All right. So instead of having these batch runs, they're doing it dynamically, and they're hooking it into their call centers and their customer support so that they can treat your problems dynamically, also proactively look for problems and the weaknesses, get technicians sent out to cell towers, for example, to start doing repairs because they're detecting these issues in real times, and it's going outside of the normal pattern variances. That makes sense? So the size of the data set, to answer your question, I want to say, well, you're looking on average, I think, of 6 billion call data records a day, which was in the terabyte size range. So it wasn't a petabyte system, but it was in the terabyte size, large terabyte size, probably mid terabyte range or so. Yes? So those are 2 questions. Let me repeat them and make sure I get them right for the camera. So the first question is, how long did it take to implement this solution? And then secondly, if they want to change the analytics, what's required to do that? So I'm going to answer the second one first, if that's okay, and then we'll handle the first one. So streams is a very interesting technology from the point of view that we're taking predictive analytics using technologies that IBM has like SPSS and applying dynamic data models to it as the system learns. So it starts to make corrections based on changes to the data model over real time, which is a very powerful statement. So now we're in the position of saying, instead of just looking in the rearview mirror like business intelligence systems have done for decades now, we're looking out proactively into the future, updating our data models dynamically so that we don't have to have business analysts and IT reps coming in and making every change to every piece of analytics software as you go forward when you learn something new. That gets into additional use cases that we haven't talked about here, and frankly, a lot of those are happening now as we speak, and it's become a very sought after business, all right? And this has really been kicking up in the last year, all right? So that's all happening now. How long did it take to get this one going? We have multiple telcos that we've done this with over time. I think a few of them are on the IBM Big Data website. So if you go to www.ibm.com/big data, you can see that. We also have a really cool YouTube channel, and that is, if you go to YouTube and just search on IBM Big Data, you'll pull up the channel. And I think I was told yesterday that we're up to 70,000 views on the channel, and it's on track to hit 100,000 by the end of the year. So we're pretty happy about that. We generally put out a new video once a week, and they tend to be either customers, partners, or IBM employees, engineers, biz dev guys, product managers, et cetera, talking about certain use cases and experiences. Some of the chats are very technical, some of them are not, and they're designed to talk about the business and the impact and the use cases. So there's a whole dynamic set that's out there, but you can learn quite a bit about what IBM's doing and what the market and the technology are doing just through watching those videos. So that's another good way to do it. I think the first one on this may have been a 9 to 12 month engagement, and then as we learned and refined that process, it collapsed 3 to 6 months after that. We tend to do them in combination with a services partner or GBS, depending upon what makes sense. Sometimes it's IBM, sometimes it's not. And then we have our software group enablement team that also works on that. Sure. Any other questions? Yes.
Captured. The question is, we use the Hadoop, the Scoop connector. So our Hadoop connector is based on the Scoop technology. Does the Couchbase performance get impacted by using the Scoop connector? As I mentioned earlier, the connector is actually using our TAP protocol, which is an in-memory protocol which allows you to stream mutations per shard. So it basically is actually looking up for each shard. So you have 1024 shards in the server. For each shard, it has a TAP stream that it's capturing. And so all these mutations are then being pushed using Scoop into Hadoop. Now, given that typically working sets in Couchbase are in memory, and also you have it's more an in-memory system. It shouldn't be as much of an impact because it's directly being streamed out. Now, if you're at 90% of your cluster capacity, then it might have a slight impact. But that's the case with any kind of export that happens. If for additional data, if more than 30% is not in memory, then it'll do a backfill, as we call it, from disk, which basically streams out the entire data for this shard and puts it on the wire. And so that's actually how it works on the back end. All right. Any more questions? Go ahead.
Of that, IBM obviously is a very large corporation that has different technologies and oftentimes will compete not only against itself, but with some of its own partner technologies. So we always reserve the right to work with other technologies, but we've worked with some of the folks in Couchbase before. We've had great relationships with them. We like the technology. We see a good synergy story here, and we're going to continue to move forward with it because the value proposition appears to be high so far, and it's working. The fact that they're also here in the Bay Area, and we're mostly down here in San Jose helps. It's certainly not required in this global market, but it is nice to get together face-to-face when required. So I think overall it's moving in the right direction. And we recognize that a lot of the legacy methods that we've been using over the years with our databases like DB2 and Informix and what have you are not going to be designed to handle all of the new big data challenges. And so we're very open to new technologies and working with the providers that bring them to market.
I'll add a little bit more to that. And I think it's depending on your problem or your application, different technologies are going to be good matches, right? And so you really need to look at what your requirements are. If you have this kind of a system where you really need a very high throughput system for the front end for your application, but you also need very heavy analytics that you need to do because of the volumes of data that you're processing. It could be sensor information that you're collecting that gets first stored in Couchbase for fast access, but then needs to be moved off after a month into a system, do some churn analysis, find out some trends, and then push it back again so that users can view their profiles for the amount of electricity that they're using. That could be a use case, right, where you need to be able to have everyone in a city who could look up this information. Now, if you don't have those requirements, perhaps another system could be a better fit. So I would say, look at your requirements, analyze them, just the usual process, and see what's the best technology that matches. In some cases, you might only need an OLTP system. In some cases, you might need only Hadoop, right? Because all you're doing is doing heavyweight analytics and you don't have a big user problem. But in many cases with today's web applications, you actually need both, and that's where this comes in, right? Great. I saw a hand being raised at the back, yes? Sure. Right. Let me answer the second half of the question, and then I'll hand it back to Steve for the first one. So his questions were, where does Couchbase fit into a system where currently they're using Hadoop to do some of the analytics, and they want to move, they maybe batch export some of this information into a relational database and actually use some BI tool, whatever it is, right? It could be SAP or whatever system that's running on a BI reporting reporting system on the relational database. Where does Couchbase fit into that, and what about ad hoc querying? Right? You should wait for the last session at the end of the day where Damien will actually talk a little bit more. I don't want to spoil the session and reveal all, but he'll go a little bit more into what our vision is for Couchbase. We do think that ad hoc querying is incredibly important, and it's something that we would like to push into future releases. But in terms of reporting, we are actually working with partners like IBM, BI partners, to do reporting directly on Couchbase. So you don't have to move it to a relational database. You don't have to run an ETL on it. We have, as you saw today with views, with materialized views, you can think of them as pre-computed views or cubes or however you call it, right? And you already have the pre-computed aggregates. You can literally use queries once we have them, and even queries today with 2.0. Use those to get access to these aggregates, some counts, other statistics, and then use that for reporting. And so we're actually working on that, some of those integrations right now, and we'll, over the next few months, we'll talk about that more and more. Hand it back to Steve to talk about how IBM might add value here, particularly with the reporting use case.
Thank you. So to answer your question, IBM is investing significantly beyond the raw distributions, right? So that's the core value. So then you say, okay, so what? Who cares, right? So you're getting into a lot of research technology that's been productized to do things like text analytics, which don't normally come with Hadoop, system machine learning, so that gets into predictive analytics. We're putting a lot of energy into that. We're in the process of putting together or taking our proven GPFS file system and turning that into GPFS SNC for shared nothing clusters, which gets rid of a few performance and edge case scenarios and gives you essentially a federated database view to go across your full cluster. Of course, there's the notion of a lot of customers come in and say, I want a single vendor, I want a single choke point, and that's where IBM comes in a lot of times, just having that blue paper, if you will, and level of security, especially when you get into the Fortune 500. That's something that they do value a lot of. Other technologies that are in there, I mean, working with LDAP is a simplistic one. A lot of the accelerators that we're building out, so we're providing the applications that help provide use case value out of the box. So from a business owner point of view, the person who's generally writing the check, instead of having a massive IT project in front of them to get value 6, 12, 18 months down the road, you can then get it out of the box because we've done that pre-development for you. And we're going to continue to do so. We also have a strong partner network, and that full ecosystem plugs in natively with Streams. It's going to plug in natively with Vivissimo as we finish the blue washing activities post-acquisition. There's going to be other acquisitions coming in, and all of those will integrate natively because they're all a family of IBM products within the Big Data portfolio. So those are some examples. I think if we go here you go. That's my email address, sbeier, so B-E-I-E-R, at us.ibm.com. If anybody wants to email me afterwards, I'll happily respond back and get you any additional information, or if you have a follow-up question in that area. But it's fundamentally feature and function, hardened for the enterprise. That's the elevator pitch answer. Any other questions for either of us?
All right. Well, with that, thank you very much.
Thank you.